Hello everybody, let's get started. So in your seats please, we've got 3 minutes on this warm-up and we'll start that timer going now. Alright, so I want to find the GCF so that I can factor out this expression. So I've written each term along the side here, and I want to look at my coefficients here. I've got 15 and I've got 25. The largest number that goes into both of those is going to be 5. So that's going to be part of my GCF. Now I want to make sure I look at my variables. I've got x's here in both of these, so my GCF has to include an x. I have an x squared and an x to the first power. The lower of the exponents is 1, so I'm going to need x to the first power as part of my GCF. And then I'm going to look at my next variable. Looks like they both have y's in them, and again the lowest degree on that is 1. So my GCF is going to be 5xy. Now I'm going to write that down next to some parentheses. Give myself some space to fill in the parentheses. And what I put in there is going to be what I get when I divide each of my terms by my GCF. So I'm just going to write those underneath there and do some dividing. 15 divided by 5 is going to leave me with 3. X squared divided by x leaves me with x. Y divided by y is just 1, so I've got 3x for my first term in the parentheses. Subtracting 25 divided by 5 gives me 5. X divided by x is 1. And y squared divided by y is just y. So I come out with final answer 5xy times 3x minus 5y. And you want to make sure you look at what's left inside parentheses and just double check to make sure there's nothing more that you can factor from there. In this case, this one's done. So we have 5xy times the quantity 3x minus 5y. All right, then number 2, another exercise. We want to find two integers that add up to 7 and multiply to give you 12. And we're going to be doing this a lot in this lesson, so I'm going to get in the habit of actually writing it this way. Calling this x factoring sometimes. I want to find two numbers that add up, so A for add up to 7, multiply to give me 12, and when I find those two numbers, I'm going to fill them in here. So numbers that multiply to give me 12, I have 1 times 12, or negative 1 times negative 12, 2 times 6, or negative 2 times negative 6, 3 times 4, or negative 3 times negative 4. If I add each of those together, this first one, adding them together, gives me 13. So if I kind of do a plus there to add them, this gives me 13. This one gives me 8. This one gives me 7. That's the one that I want. I wanted the pair that adds up to 7. So 3 times 4 adds up to 7, multiplies to give me 12. These are my two integers. More on that coming soon. Right now I want to go down to this next problem here, and we're going to multiply these two binomials. When I multiply them, I want to make sure that I multiply each term in the first binomial by each term in the second. So I'm going to be using the distributive property of multiplication. And I'm going to use the box to fill in here. So I get x squared, positive 3x. Negative times a positive is a negative, so a negative 2x here. And then again, another negative times a positive is going to give me a negative and 6. Like terms are occurring in those two boxes, so I want to combine those, and my final product here is x squared plus 3x minus 2x minus 6, but I want to combine my x terms. The 3x minus 2x gives me just positive 1x, and then I have the minus 6. So my product is a trinomial, because there are 3 terms. So notice on this thing I multiplied two factors, factor 1 and factor 2. I'm just going to call it factor 1, factor 2. Multiplied each of those two factors and got a product. And my factors were both binomials. So I'm multiplying two binomial factors, and I'm ending up with a trinomial product. What we're going to be doing today is looking at these trinomial products and seeing if we can figure out what are the two binomials that we multiply together to give us those trinomials. So going to the notes, we just did this problem on the warm-up, x plus 3 times x minus 2, and we got a trinomial x squared plus x minus 6. My standard form for these trinomials is some coefficient, we're going to call it a, multiplied by my x squared term here, plus some coefficient multiplied by my x term, plus a constant. Not a coefficient, but a constant, a number by itself. And that's the c part here. Now, this expression is called quadratic trinomial because there are 3 terms in my polynomial. And quadratic refers to a degree of 2. So if my expression is a second degree, then I have a quadratic polynomial. Alright, so now I need to be able to factor these trinomials, and I need to be able to go in the opposite direction of the multiplication. So I need to go from a trinomial to my two binomial factors. So here's how we're going to do this. We are going to examine our trinomial, and if you recall what we did in the warm-up, we did an exercise where we were looking for two integers. They added up to some number, they multiplied to another number. So here's what I want to do. I have this trinomial, and I'm kind of going to go backwards here. I know my trinomial has x squared in it, and when I'm multiplying two binomials, my x squared ends up here in this box. And when I add up whatever is in these two boxes, these have to add up to equal the number of x's that I have. So I want to add up to number of x's. I'm not writing too well for me here. See if I can fix this. Alright, so my two boxes here combine to be like terms, and it adds up to the number of x's I have in my trinomial. My last box here always ends up having in it my last term, my constant term, in this case a negative 6. So this negative 6 here is what I want to put in my bottom right hand box here. Now these other two boxes we said had to add up to equal my number of x's, and if I look at my trinomial, number of x's for this example is 1. So I need two numbers. Actually, I'm looking for integers that add. I think we better clean that up a little bit there. See if I can erase this. Okay, I need two integers that add to 1 in this case. And when I multiply them, they're going to give me my constant. So I need them to multiply to a negative 6. So I'm going to write down my 1 in an x here at the top, and that's what I want to add to, and I want to multiply to the negative 6. On the next page of your notes, there are all the combinations that you can find that add up to 1 and multiply to negative 6. So let's just turn the page and look at our possibilities. They're listed here in blue. These are all pairs that multiply to be negative 6. If I add them together, plus 6 and a minus 1 is 5. Negative 6 plus 1 is negative 5. 3 and negative 2 gives me 1. Looks like that's the combination I want. Negative 3 and 2 gives me a negative 1. Now I wanted my numbers to add up to 1, so the two numbers that I want are 3 and negative 2. So if you think back to our box, I had an x squared here and a negative 6 here. These two have to add up to positive 1. So if I put 3 x's here from the 3 that I got here, and a minus 2 x's here, that adds up to my 1x. And above here, I'm going to have x plus 3 and x minus 2. These are the two binomials that I'm going to use, or the binomial factors, x plus 3, x minus 2, so that when I multiply them, I get x squared plus x minus 6. So we're going to use the same process to keep factoring trinomials. How could we check our answer? multiply the binomials. And these binomials are factors. So really what we're doing is multiplying the binomial factors. Alright, so let's continue on. Look at the next page. We're going to do some practicing here. Now all of these trinomials that we have for practice are starting with x squared. Then a middle term has our x terms in it, and then our last term has our constant. So really it's set up for us already. We want to find two integers in this first example. My mistake there. We want to find two integers that add up to 7 multiplied to -8. So I want 7 is my adding, -8 is my multiplying. So I'm going to think of all the pairs that I can use to multiply to -8. I have 1 times a -8, -1 times a +8, 2 times a -4, -2 times a +4, and I think that's all the ways that I can multiply to -8. If I add these numbers, I want to find the pair that adds up to 7. And I can see that it's here, -1 and 8, going to add up to 7. So I'm going to put those numbers here. And those are the numbers that, if I were to fill in my box, I would have x with a -1 and x with a +8. If I multiply those out and combine my like terms, this all will equal x squared plus 7x minus 8. So my two binomial factors are x minus 1 and x plus 8. And that's done. Let's take a look at the second example here. I want to find two integers. They're going to add to 10, multiply to 25. So I'm going to throw them in my x here, do my x factoring. Oh, I think this one's pretty straightforward. Two numbers that multiply to 25 and add up to 10, +5 and +5. That means that if I were to multiply x with a +5 times x with a +5, I should get x squared plus 10x plus 25. Looks like that works. So my two factors, x plus 5, x plus 5. Alright, let's try the next one. I want to add to a -21. I want to multiply to 110. This one not as easy as the last one. So adding to -21, multiplying to 110. I'm throwing those in my x factoring tool here. Here's a hint for you. If you are having trouble finding numbers that multiply and add the way you want them, you can get some help using your calculator. Here's how. Whether you're using an 8384 or an Inspire, you want to go to your graphing mode. So on the Inspires, I'm going to go to my f1 of x, and I want to put in whatever the number is that I want to multiply to, in this case 110, and I'm going to say what's that divided by x. If you're using the Inspires, that's what you're going to put in. If you're using the 83s or 84s, you've got to go to the y equals button and put that in for y1. After you put that in, you want to look at your table of values. So you want to look at table of values. And you want to look for your xy integer pairs. Those are numbers that are going to multiply to give you the number that you put in. So we wanted to find numbers that multiply to 110. On the table of values, I can see 1 times 110, 2 times 55. I'm not interested in numbers that are not integers. So the next set of integers are 5 and 22. So far, none of those are going to add up to a -21. But if I scroll back and look at some of my negative numbers, I'm going to find that a -10 times a negative 11. It's going to multiply to give me a positive 110 and add up to negative 21. I could put those in my box to check, but I know those are going to be my second part of my binomial factors. So I'm going to have an x with a minus 10, and I'm going to have an x with a minus 11. I'm going to leave that to you to check to make sure that if you multiply those, you really are going to get x squared minus 21x plus 110. All right, let's do another example here, number 4. I want to find two numbers, and they're going to add up to negative 8. Put that in my x factor. Multiply to negative 20. Now, if I'm multiplying to get a negative number, I know one of the numbers has to be positive, one of them negative. And if I'm going to add up to get a negative 8, that's a negative number, then the larger number that I need has got to be the negative, got to be the same size as this negative 8. So if I think about all my ways to multiply and get 20, 1 and 20, 2 and 10, 4 and 5, and I think that's it. Now one of those numbers is going to need to be a negative number so that when I multiply I get a negative. Looks like, I think if I use the 2 and 10 and I make the 10 negative and the 2 positive, those two will add up to give me negative 8. In that case then my factors are going to be x plus 2 and x minus 10. And again, I'm going to leave that one to you to check. So if you multiply those two binomials, you should end up with x squared minus 8x minus 20. Got to go back and box that other one in. All right, so we've done 4 examples there. One more thing I need to make sure that you are aware of and to be careful of. So first we're going to fill in this yellow box here on the next page of your notes, and then there's a caution sign under this next thing that I want to make sure we go over. All right, so I want to look now at what's in this yellow box in this reflection. And I want to understand what kind of factors I'm going to need here. If I'm doing some factoring of a quadratic trinomial, and I want to multiply to a positive number, so actually I'm going to put my little x factor up here. If I multiply to a positive number and I add to a positive, so I want to add up here to a positive, I want to multiply also to a positive, that means my two numbers that I'm looking for must be positive. So I'm going to have x plus something, x plus something. If I want to multiply and end up with a positive number, but when I add my two numbers, I want to get a negative in this second case, then I'm going to write this one over here. Let's see, I want to add to be a negative, and I want to multiply to be a positive. These two numbers will both need to be negatives. Two negatives multiplied gives me a positive, but when I add them, it gives me a negative. So negative here, negative here. Number 3, let's say we have to multiply and get a negative number and add to get a positive. So when I'm adding, I want a positive, but when I multiply, I get a negative. The only way I can multiply and get a negative is if one of my integers is a negative and the other is positive. So I'm going to have one negative, one positive. But if I'm going to add up to get a positive number, then my positive factor here must be the larger of the two numbers, and the negative is going to be the smaller. If we do the opposite, and we are factoring so that we want to multiply and get a negative, so I want to multiply, get a negative, but when I add, I want to add to a negative, I still need one positive, one negative. But if I'm going to add to a negative, then my larger number has to be the negative. So larger negative, smaller positive. Didn't mean to erase that. Let's get that back here. Adding small. Alright, that brings us to our cautionary thing down below. Something to consider that we haven't had come up so far. Take a look at these next two examples of trinomials. What's different about them? Hopefully you are all saying that we don't have just an x squared to start out, which changes things up a little bit for us. But remember, our first step of factoring is always look for a GCF. In each of the four examples we just did, there was no GCF. In each of these two cases, there is a GCF, and I need to factor that out first. So looking at my first example here, GCF, going to be 16 goes into every one of those numbers, and nothing else. Now I want to end up with a positive x squared, so I'm going to make my GCF a negative 16. And I'm going to write that down next to parentheses. And I'm going to divide each of my terms by a negative 16 so that I can fill in the parentheses. And I'm going to get x squared minus 2x minus 3. Now this trinomial that's left in parentheses, that's what I'm going to use to figure out two integers, and I want to add up to negative 2, and I want to multiply to negative 3. Multiplying to a negative number, one of them has to be negative, one of them has to be positive. And if I'm adding to a negative, my larger number has to be the negative. So negative 3 positive 1 multiplies to negative 3, adds up to negative 2. That means when I factor that trinomial, I'm going to have x minus 3, x plus 1. Oh, but I must always bring down my GCF because that is part of my factoring. So in this case, I have not only the two binomial factors, but also a constant GCF. Let's take a look at example 2 here. I don't have an r squared by itself, so I'm going to look for a GCF. Thankfully, we see we've got a GCF of 4, so I'm going to divide the 4 out of everything, fill in my parentheses with my GCF on the outside. I get r squared minus r minus 12. Looking at what's left in parentheses, I want to look for two numbers. They're going to add up to be, what's the coefficient of my r here? I'm going to add up to be negative 1. I want to multiply to be negative 12. So I know I'm going to multiply to a negative. I need one positive. I need one negative. And my larger number has to be negative because I'm adding up to a negative 1. So it looks like it's going to be positive 3, negative 4. Now I don't have x, I have r, so when I write my binomial factors, I need to remember to use r, not x. So I'm going to have r plus 3 as a binomial and r minus 4. And GCF has to come down as well. So 4 times r plus 3 times r minus 4. And that is factored. Alright, so you have some examples here and you have some classwork that you can start working on. What I'd like you to do is start those classwork problems, and then whatever you get done on the classwork, use that as your ticket out the door, please, and hand those in. And then you also have homework to make sure you complete for tomorrow. So that's it for today, guys. Have a great day, and I will see you on Thursday. Bye.